All right, so let's start it. AP Smart is not a company, it's a DC side of business union, independently from the AP Systems original or the core business, which is the microinverter separately. Um, we publicly stepped into the U.S. market about 2019, right before the pandemic. And here is our structure. So you can see we are belong to the DC side business. It's RSD, but later on maybe they have like smart module stuff. This is on the roadmap. Yep, that's a structure. Give you an introduction. And after 3 years, we developed a business in the U.S. market. We have like a lot of the partnership, including the OEMs like Canada Solar, QCell, Trina, Jinko, also including a lot of the string inverter, which is our major partnership, like FMA, Chain Solar, Iskawa, Delta, Furnace, Fortis, or even Huawei. And also we are partner with a hybrid inverter like Solarc. We started cooperate with them since 2019, and right now we still have a lot of customers using our system combined with their hybrid inverter in the US, both in the US and the Canada market. And we also have directly EPC like Sunrun, Duke, and Vanguard, BPI, those large commercial megawatt levels project is getting more and more right now. So, but for the Canada market, based on this feedback, is mainly focusing on the residential market so far. I'm not sure how familiar with the 2017 the module level rapid shutdown for the 690. We just quickly give you introduction, especially for the SunSpec. SunSpec Alliance is organization is step forward to help industry adopt the NEC standard for the rapid shutdown solution. We are under the Alliance, we are exactly following Alliance requirement, and we are being certified by SunSpec. So under their requirement, they have two equipment you can see. One on the module side, they call it receiver, which is on back side of the PV panel, receiving the signal, and the function for that receiver is to sell the power from the PV module. Another equipment that they call the transmitter is the signal generator. The generator, the PLC power line communication signal through the DC line. So what happened, the system, how it produces, when you turn on the grid, the AC is on, your inverter is turned on, and the transmitter started to generate the signal. And signal will be transferred through the DC line, get to the receiver. When the receiver receives the signal, we call that heartbeat signal, then they starting alive, means they release the power from the PV panel. In another word, by default, this device will sell your power from the panel. That's the most question we got from the installer. Question why my PV panel have no power output after installed your device. That's supposed to be actually. That's overall the picture show you how that works. See the right dot on the panel is the receiver. We have two products. One is RSD-S-PLC. It's a one-on-one single receiver. We also have a product for RSD-D. We have two models on that. I can introduce quickly different, but for the Canada market so far, because mainly is for the residential, the installer on the residential market, they favor about the single. So this presentation will be mainly focusing on the single. Let's quick go through the receiver, especially for the one-on-one single. You can see from the picture, it's very small, right? And the core of our developing team, actually, we design our own chip. And that chip will be significantly reduce the components on the PCB board, which increased our reliability and performance. And that's why our device, the strategy will be for this MLPE will design as simple as possible. So we only have the function for the NEC rapid shutdown function and follow the subspec requirement only. We do not have a monitoring function. A lot of people ask me about that. I said, no, we do not have that. And it's not optimizer either. So we are depending on the string inverter monitoring portal. For instance, like SMA, Fronies, most of those new models from the major vendor already support customer with their own portal. So you just directly use their portal to monitor. I will teach you how to monitor it very effectively. Small and light is easier to operate. Most people I learned from them is they directly clips. There is clipper. Let me show you quickly. You can see that
on the picture, it's very small on the top. Hold on, people can't really see your camera that well.
Oh, sorry.
It's very small. You can see it, but it's very small on the screen. So, but yeah, it's a very small clip that goes that is in the back of the rapid shutdown device, and it just clips right into the module frame. It's a really easy thing to install, and the installers really like it from what we have heard.
Mm-hmm. And the specialty for this is they have two tools on the front. So as long as you clip into your frame, there will be, if you want to pulling, the tools will be stopped there ever. So it's very hard to pulling out, very stable. Also, this device is not grounded. It's just like, think about it as a switch on top of your J-box. So I like a lot of questions from customers say, are you grounding point, or you can connect together with your system grounding point? It's not. It's just like a switch. And that clips is only the purpose of the fixing device. It's not from the grounding point. Because the size was pretty small, the shape was differently, and the working with the bifacial is very effective. So they're not causing any shading on the back. Perfect for the bifacial panel. It's also the lens was input about 200 millimeters, is feasible for the spread J-box application as well. The new device, when we decided, we are already considering certain situation we will have to be survived from the reverse current. So we reference the string inverter standard requirement, and right now we can survive 40 amp reverse current for 2 hours, same as the string inverter requirement. And we also feasible for the 25 amp fuse rated PV panel right now. This device, internally, they have a sensor, and they have high temperature protection function up to 100 degrees C. So when they reach that, they immediately shut down the whole device. And it's feasible with PV and storage hybrid inverter, or even a totally off-grid inverter. It's just different setup or different product. We we will go through that later on. Is there any question? Can just wrap up quickly?
I think it's good for now.
Okay, good. So I just skipped the door, so because it's not a major concern right now. Hello, can you hear me?
Yeah.
Yeah. Okay, great. The next is the transmitter. They call it transmitter dash PLC. This transmitter generates a PLC signal and follow the NEC standard and the sound spec requirement. You see there are default of 2 core. They have 2 channels in here, core 1 and core 2. But the most residential jobs, they do not need both core installed for the transmitter because the most residential jobs will be less than 10 string for sure. And each core, each CT they have here, they can go up to 10 string, even more. That depends on how many totally maximum allowing current can go through that CT. Right now, we can go reach up to 200 amp totally together. Some large job, especially for the commercial jobs, they really put more than 10 string into single core. And also, there is the risk, but as long as they below these limitations, will be fine. For residential, yeah. So normally you will get is only single core with the package. Just let you know that.
Yeah, and actually, sorry to jump in here, E. Most of the inverters that we're selling nowadays, for example, SMA Sunny Boy, is already SunSpec certified. So you will not need a PLC transmitter kit. It's already integrated in the inverter, which is really nice. And that's the whole purpose of SunSpec, right? It's a communication protocol that is kind of not proprietary, but it's being shared amongst the different inverter manufacturers and components manufacturers such as AP Smart. So that case, you don't need to buy a $200 piece of equipment to use your AP Smart on a residential system, which of course is a much bigger deal on a residential system than it is on a commercial system. On a commercial system, a $200 piece of equipment is not that big of a deal when you're using a 100 kilowatt inverter versus a 5 kilowatt inverter.
Correct. Yeah. Thank you. And also, there are more and more players that come in. For instance, Saudi is actually talking to us right now for their transmitter. We are under testing. So after the testing, if we do not have any issue, we can work it together right away. Next, the PLC signal, the distance is about 1,500 feet, which is the whole home run. It's from the positive from the inverter back to the negative of your inverter, the full home run, about 1,500 feet. Within that distance, we guarantee all the signal is very strong. When we install that very important thing in here is it have to be polarized, which means neither using the negative or the positive only. Do not put them together to mix the signal. Otherwise, they will immediately cause confusing to the receiver and actually significantly reduce the signal.
And yeah, that's actually one of the things we've had happen as well is if you do have a SunSpec certified inverter, and then you also install a PLC transmitter kit, now that's actually a negative thing. Don't install both. Make sure if your inverter is SunSpec certified then only use that one. And if it's not certified, then you need the PLC transmitter kit. Installing both will actually cause issues. So just keep an eye out on that and make sure if your inverter is SunSpec certified, do not buy this unit.
Thank you. Correct. That's a good point. The next, quickly introduce this product they call the outdoor case. Like Dan said, normally if the string inverter had been certified by the SunSpec, they already integrated their own or our third-party transmitter inside. But in certain case, for instance, if you have a solar, a hybrid inverter, which is more and more popular in the Canada market, right now you have to use this product. They call the outdoor case. It's a package. It's very simple package with AC/DC power supply and a transmitter that's PLC. It's two CT and a bunch of the accessories. You can rail mount on the wall and anywhere around before you get into your hybrid inverter. The function for this product is because solar is not directly hooked up with our transmitter or any third party. They used to be, but by certain reason, recently we did learn from customer side is used to be you can directly connect the transmitter by using their 12-volt DC power inside. But our device, I think the same thing as the Tigo, we need a certain current to support the whole power to generate a signal, very stabilized. Our device, we need a minimal 400 milliamp per channel, which means per core. Even you just use a single CT on the residential system, we still need 400 milliamp input into the transmitter. But right now, recently, solar arc, the output from the 12-volt DC is only can reach about 100 or 200. And it's not stable. Sometimes it's high, sometimes it's low. We don't know why, but that's happening. And a lot of customers call in to transfer that, get into this product, and using the AC/DC power supply directly to support the transmitter with a stabilized signal. Later on, I'm going to introduce how you wire out and install that product. But right now, I just let you know if you have a solar, you need to pay attention on this product.
Okay.
When you purchase, sorry.
Yeah, so just to highlight quickly, so the inverters that will need this product, that at least we are carrying, would be the Fronius Primo units would require the outdoor transmitter kit because they're not SunSpec certified, and the same goes for the 15 kilowatt Simo 208 volt. That is also a product that is not SunSpec certified. All the other Simos are SunSpec certified, so you will not need this product. You will not need it with any SMA products. You would need it with Solarc. You would need it with Schneider products as well, for example. So those will be the inverters where you would need this product. So just keep that in mind. If you have any questions, please feel free to reach out to myself or your Franken Solar account representative, and we can help you out and tell you if you need it or if you don't need it.
Additionally, just one tip here. You see that the equipment with a single core with 85 to 264 VAC power supply. It's only for the residential and only for a hybrid inverter. So when you purchase this product, pay attention on this, because if you order wrong AC/DC power supply, they will not work.
Okay.
This a simple drawing, both on the single and the dual, but we are only focusing on the single. Pretty easy. All right, so application 2, like we said, if you have a non-suspect certified inverter, you're going to use outdoor case package. That's how you wire them out. So you take the wire from the grid input side after it gets to the breaker. Then using the AC to charge your AC/DC power supply and charge your transmitter here. And also, you can put more than one inverter actually, but that more mainly is for the commercial job. Normally, one inverter is good enough for residential. This setup is for the hybrid inverter. It's very tricky. You have two ways basically. Traditional way, you put the AC input directly after the breaker from the load, go to the AC/DC power supply and the charge. But the most hybrid inverter customers, especially for the solar, when they install that with a battery bank or storage, they want the PV system continue to operating when the grid off, right? That's common sense. It's a reasonable request. When that is request from your customer, you have to change the wiring to connect directly to the hybrid inverter AC load side. So when the grid was off, normally the hybrid inverter will have a function quickly in the millisecond twisting from the grid supporting to the battery supporting. And they keep the AC load support all the time. And by doing that design, you will be able to let your PV array still alive, even the grid was off. Sometimes the ASG will request additional control during the wiring from outside. So they will be able to control your system, maybe just by single safety switch. Something like that. Yeah. Is there any question about the wiring and design? Good. Right. Compatibilities. How would you judge your panel is good for the AP Smart system? It's pretty simple. For the single, the voltage reading for the input from the panel is from 8 up to 80 volt. Anything below 80 volt will be fine. The reading.
Yep. Sorry, there is one question, and I think I can address it. So the question was from Vlad, and it's asking, can you please provide a reminder as to when rapid shutdown is required and when not? So in Canada, it generally is required on rooftop projects, and the requirement is that a rapid shutdown has to happen within 1 meter of the solar array. That can be done in a number of different ways. There can be the inverter can be placed within 1 meter of the array. So if that is possible, then you do not need to get any additional rapid shutdown, since the inverter itself will be the rapid shutdown. Alternatively, a rapid shutdown box can be used. There are a few options out there. I think Fronius rapid shutdown box is the only product out there that I'm aware of, and that's a 600 volt only solution. And then if neither one of those is the case, then you need module level shutdown with products such as the AP Smart. And then you'd replace those, you'd place those with the back of each module. Thank you, Yi.
Thank you. The rating for the RSD-F-PLC, the single is 15 amp. You can tell from here, the door device, we have a 15 amp and a 20 amp, but that's mainly for the commercial jobs. They want to go to higher the current product with bifacial, much higher current on this side. But normally in the residential market, they still go within the 50 amp right now. the RSD value is 25 amp. So if you calculate it, you can calculate from your panel data sheet their RSD value times 1.25 with the safety factor. For the bifacial, not too much favor about on the residential side market, but what we learned from the commercial jobs is the most bifacial panel in the field, they never really gain the power additionally 10%, normally below 8%. That's why when we doing the calculation, we're just using 10% as the bifacial gain factor in reality. This side, just that you know, our reverse current could be go up to 40.5 amp, like I said before, about the 2 hours. That's exactly the same as the string inverter standard requirement. For the mechanical compatibilities, for the residential jobs, long cable is very important. That's why we required even the split J-box, which is the most popular panel design right now, at least with 1.2 meter length, so they're pigtails. So you will be able to just very easy to connect, install. For the connector side, our products by default we are using WMC4 as our connector. There is a lot of argument, also complication situation when you purchase the panel with a different connector. You need to be very carefully right now. I'm not sure in Canada, but in the US, UL is required, or no, sorry, NEC is requiring to match the connector right now.
It's the same in Canada. You're required to have the same branded connecting pair. I think there's some leadway with like Stäubli, where you can use their Evo 2 with MC4. That will work. So they have 2 different types of connectors. Generally on commercial modules, you'll see the Stäubli Evo 2 connector with, and on residential modules, you see the Stäubli MC4 connectors, and they're interchangeable. They are certified by UL to work with each other.
Oh, I see. Great. That's good. Also, we have OEM like Trina. We directly hook up. They change the connector to follow the Trina's panel, and actually you get from them. Well,
yeah, we're carrying Trinas, and the Trinas we carry have MC4s.
Another trick part in here is very important. The bending issue. We did learn a lot of bending issue from the field, especially in the residential job, because I did on the roof to use a couple of the system. It's very hard. You have to follow the requirement underneath of the roof surface gap, right? And it more than you have to bend in the cable. So when we try to make a wiring measurement requirement fulfill, you need to be careful not bending too much. The reason because when you're bending too much, especially like this 90 angle, the cable is okay. They have a reinforced portion, but inside of the cable, the copper will twist it, and that force will be transferred directly on the connector inside of the equipment, inside of the box enclosure, and on top of the soldering joint. So even the solder joint quality is very good, the force will be transferred inside of your PCB by layers. Inside of PCB, they have a layer copper, layer plastic. And when the force transferred and they left a little bit of space, then they causing the internal arcing within the PCB layer. And then when they heat up comprehensively and continue running, they will cause like some kind of concern. and the thermal run away, then they fail the device. So please be very pay attention on this during the installation. We did find out this phenomenon, and actually we did have an improvement. The new design, we try to improve this kind of situation. We actually get wider on the outside end. We get about like 5-inch wider to get it reinforced longer. Looks better, and right now the new product that be come out from the manufacturer will be all belong to new product like this. Let's see how they react in the field. Any question about the compatibility with our system? Right. All right. So for
just a quick question. There was a question in the chat. Apparently, according to your slide, panels with leads shorter than 1.2 meter are not compatible, or just not non-recommended.
Just non-recommended, because
Okay.
when you have a shorter leads, you have to use a jumper.
Yeah.
We did get a lot of this request during 2020-21 because of the pandemic caused some supply chain chaos. There is a shortage in the U.S. market. Somebody have to using the panel what they have with the short leads, then they have to use the jumper anyway. Yeah. Compatibility with the string inverter. Well, we do have a website, ntsmartglobal.com is our official website, and there is a section called inverter compatibilities. You get into this page, pick up whatever the inverter you want to use, and then we come out with compatibilities with which model, which device. This.
Yep. Very nice. That's very handy.
Next, some detail about our receiver. The install, we recommend install outside of the frame because we have clips. Originally, you can clips outside or inside. But after 3 years, we learned from the field to see if there is any concern about the failure. To put it with the inside where they have higher possibilities you will damage the back sheet, right? So right now we only recommend the customer install our device with outside of the frame, which using the frame as the barrier. And when the worst case happened, if they failed, they still have a barrier to protect your panel backsheet, and you will never damage your panel. Another thing we learned from the field is it's not only the MLPE product laid out. You have to separate your negative, the cable, from your conduct on positive side. Basically, we recommend within the array or within the string, you better separate the positive and the negative wiring management. Because what we learned is, for instance, your connector, you are not perfectly connected or with a mismatch, the arcing, right? When the system starting their full string level arcing on the connector, and they could be burned out your connector here. And if you touching your negative, the thermal will actually melt out on your outside of your negative wiring skin. Then you cause the arcing between your positive to the negative. That's gonna be cause the full string burnout immediately. I saw that from the field, from even not the MLPE device with it. It's very traditional failure mode to counter the fire on the roof. Introduce two very handy tools. One is RSD I+. Is similar as Tiger before. They have detected the signal for the PLC, but additionally, this device could become a troubleshooting tool because we added a function they can generate the PLC signal and testing your device independently. And if you just connect with your device as the drawing here, press the button, the signal will be transferred into your device. And if the still function, it will turn on the panel and release the voltage. And when they reach out and release the voltage greater enough, it will feed back to the device. The device will be beeping. That indicated your device still function.
Steve, no, we don't carry it right now. I've actually never been asked about it. We have sold many thousands of these AP Smart devices, and we have yet to hear of anyone having a failure. So so they're working really well. But if someone needs that tool, we certainly can talk to AP Smart and request that and get a price for you.
There's another tool they call a Star Kit. This tool is for commissioning and troubleshooting. What it does is, look at here, is inside the box, there is a small version of the transmitter. And we short the home run inside of the box. We have a like lead down circuit inside. And we are using 12-volt DC battery bank only. You can buy that battery from Walmart, from any grocery, and just put it into the box, turn on the switch, it will turn on this transmitter. And the function for this is very simple. You can use this tool to testing and turn on your string independently without inverter. That's the main purpose. And one of the reasons we designed this tool is especially for the commercial job. After you install like very many strings, you need to make sure every connection is good. So later I just show you how to commission this one. So you can turn on your string and look at the output VOC level to confirm your string, all the panels turn on and function. And for large system, you also can do certain level of the measure testing. I think I did the testing on installation under, I think, 1,000 volt for commercial jobs. Both of those two, be honest, is mainly used for the commercial one. But some of the residential also like to use this. Some of them very handy, for instance, like this one. But a lot of them request this one because the large project, they have to use this to do the measure testing for commissioning or IV curve stuff. This is briefly talk about is best practice. Again, we recommend the customer to keep the negative wiring separate away from the receiver or any conductor on the positive to ignore any or avoid any fire hazard. Then after the best practice is each device, sorry, I didn't mention this one. For the single, when you connect with panel, the DC side, the power will turn on this device. And there is no power and no current output, but they have a, we call that safety voltage. It's about averagely 0.78 volt, but it's a range. It's above the 0.6, but below 1 volt. Keep in mind that this number is very important. So when you connect this panel, it just, if you want to make sure your panel is functional, it just directly use the DMM to measure their output voltage to get this value. Then when you connect output become the full home run, before you connect into your string inverter, you need to test in their open air DC voltage just by use this value times how many devices you have. For instance, if you have a 10 panel in one string, when you're testing the open air DC voltage, you probably will get between the 6 to 10 volt. Then I had a last question from customer side. The range was pretty hard to judge. If you have a 1 or 2, you lost the signal, right? So if one of the field will bypass, or one of the connection is not good, they just bypass that device. So how could I know my installation is perfect? That's using the start kit. Like I said, just measure, turn on the start kit, turn on the full string, and then measure their VOC. And they probably will equal to the module's max power voltage times how many panel in that string. It's very, very accurate. Is there any question about installation? That's the practice.
I don't think so, no.
Okay. Here, I list most question from the past 3 years the installer asked me in the field. One of the questions they said, why cannot get the full power from the system after installing? It's mainly designed for that way. That's the rapid shutdown for. How could I know the installer is good? The best way is measure their VOC values using the start kit, or you're just using the DMM to measure their the open air on the DC home run to get the value and calculate it by the safety voltage. Another thing is, how could I find out the field device location inside of the string? That's very tricky. They have a different way. Later on, I'm going to introduce more on the detail.
And I would like to point out, I mean, one of the advantages here, one of the major advantages, and I don't know if he's getting into it, but the amount of failures of such a device, because there is very limited amount of technology inside, it's a very simple device, is that it is very unlikely to fail compared to a optimizer or even a microinverter, right? Which has much more going on versus this rapid shutdown device.
Thank you, Dan. I will get that part also later on. What's the fair rate so far in the reality? What's most mistake made in the field during the RSD installations? Losing connectors. That's most common, very often. I have experienced in the real installation. Connection with the wrong cable. Due to some of the reason, I don't know why, but they just crossed. What means is they use one output to install to another site or input somewhere. They miss cable. Then they burn out the device. Short RSD output cable. Yeah, please pay attention. Not shorting the output cable. That will directly damage the device. Reverse the string positive and negative, they happen, but not really very frequent. I think that's based on the installer experience. Bending device output cables, yeah, this will happen with frequently, but not right now. A lot of people already know that, so they very be careful. The positive, negative will vary, very rare. How to monitor the compatibilities of monitoring the device? A lot of people ask me if your RSD device have the function of monitor each module performance, or it is to know your RSD is the functional. No, our device following the strategy we have is as simple as possible. If you add into the monitoring function, will be get more complicated, get lower reliability, even get a higher failure rate. So we decided no, we get to the simple and more solid solution. But it's very easy to monitor just by monitoring the string inverter MPPT portal. So this is a real data to have. So for one day, we did find out that there is a drop from one of the MPPT monitoring, and we saw the drop was about 20 volt. It's pretty much equal to one of the maximum power voltage per panel. Also, after a while, we learned that there is another one failing that in the same string, so it expanding as we learn that it's expanding to 45 volt, which means they have a two device fail. Then the customer sent the troop into a system to replace those two devices. Immediately the system come back. So by this case, we learned that it's just monitoring your string inverter hurdle for the voltage will be easily to know the status of your RIC device function or not.
There was a question from Steve. He was his question reads as follows: the specs show 0.7 volts as the potential of the rapid shutdown unit with the PV module connected and with no heartbeat. However, in practice, I measured this voltage to be at 0.7 volts to almost 1 volt. Can you clarify?
Yeah, it's okay. 0.7 volt, right?
Yeah. So yeah, I think the thing said it's the average is 7.8 and the range is 6 to 1 volt, right? Something like that.
Yeah, correct.
Yeah. So I hope that addresses your concern or question, Steve. If you have further questions, just send another message there.
The real reason we can control within that range is not because of weather or irradiance level. It's from the manufacturer control their process, and it's a batch by batch, build by build difference. Sometimes you can get a 0.7, sometimes you can get a 0.8, and sometimes you can get 1 volt. And yep, so that's why we give this range, and that's another major reason we give this tool. You can, as long as you turn on that string, everything will be solid. You can see exactly the voltage VOC level per string as you're supposed to see.
Makes sense.
This one just give you an overview how we'll do the troubleshooting and give you a very easy step so you can get knowledge about that, what's going on for your system. We give the example. For instance, we have a 10 panel on the string, right? Each panel, the safety voltage, we assuming is 1 volt. You're supposed to see the averagely the open air safety voltage about 10 volt DC. That's the reference. So for instance, when we install that, one of the panel a failure, like they lost the bypass diode or they have a crash cell, whatever the reason, the panel failed. Or you have a losing connector. The installer uncertainly they didn't connect, or they are using different type of the connector. They just not fully touching inside. And for any reason, the device have failures or whatever that happening there, normally it bypassed your device. So all those three conditions will bypass this device, those three devices. So you lost the 3 volt in that string. So when you measure the open air voltage for this string, if those three conditions happen, you only get a 7 volt DC. Does that make sense to you guys? I just want to simplify and give you the knowledge how to judge the situation you probably later on will be facing.
Looks good so far. Thank you.
Yep. Also, if they have some reason they open that device here, the means open means device be shorted. For instance, you accidentally positive negative touching it before, and then the installer doesn't know, they just hook up into your system. But the device already be shorted. Shorted means they lost the rapid shutdown function. And what gonna happen is we release this power directly. And when you measure the positive and negative on the open air DC side, you will see the higher voltage, much higher than it's supposed to see the safety voltage. If you have that kind of situation happen, you immediately should know that, okay, some device is shorted. For SMA inverter, actually, they internally set up the program. If they find out they immediately have a higher voltage, they will alert you. They call the RSD fail. So for the SMA customer, you need to pay attention on this. If they have this alert come out, it means somewhere was shorted with high voltage. For SMA also, another thing you need to pay attention is they set up exactly follow the SunSpec alarming requirement, which minimum have 6 modules. And when they make the program, the starting voltage they stop, I think is 6 volt. So if your string, like this happened very often on the residential jobs, is you only have a 4 panel per string, and you put up into one of the MPPT. That will alert and not turn on the SMA because they know you were lower than the starting voltage, and then they will alert you, and they will hold it there, not turn on the inverter until you reach the starting voltage limit. Be aware of that. I'm not sure furnace if they have this function or not. The third string gives you the example if they have the huge failure because of the internal arcing. The beautiful part for this RSD, especially for the SunSpec, is requirement is even you have arcing inside of your device, it's low voltage arcing. That will very minimal damage for your system. That's been proved by the UL. That's why right now the UL requirement on the roof must be below 80 volt. Any kind of the equipment have to be below 80 volt. And That's a major reason why. Or you have a loose connection during the installation. The very often happens here, loose connection by output or the negative comeback. They didn't get the right connector, and they have a mismatch issue and lose the contact inside of the connector. You will see the string with 0 volt. When you have that kind of information, you immediately you should know somewhere with the open circuit, and you can just looking for that point, grounding point, where exactly happened. Okay. Is there any question about the overall the detection? Or... All right, so here is some picture I show you and some tool. How you already know from this kind of the monitoring system, you already know which inverter have a problem, right? And probably you will know which MPPT you have a problem. That's for the troubleshooting. Next, by this guideline, you can know which string have the issue. Then the question would be, within that string, how could I know which one failed? It's very easy. Every failure from the MLPE will be show up as a thermal issue. And the best tool for that is using the air camera. And as long as you connect with when the actually bypassed, this panel will be light up under the air camera because the energy would be trapped inside. And under the air camera, you will see the light spot, which is the exactly suspect device fail location. Or because air camera is pretty expensive in the market now, we did have a customer just using the thermometer. It's just industrial level thermometer you can buy from the Home Depot in the US or Lowe's in the US. Just use that laser gun to shoot the whole string. You can exactly find out the exactly hotspot. And normally the hotspot will be dedicated with the failure point. That's the cheaper way. And when you get the location, you just use the DMM. Either you are taking out from the string and measure their DC output to see if they still within the safety voltage range, or you're using the I plus to testing it outside or put it back, just get an evidence say this device has failed. So that's the last step. You can locate where is the failure. The reason I give you those steps because that's the most very common question with people. When you introduce to a new customer, they always think, "How could I know if they have like any failure?" If you do not have a monitoring system, right? That makes sense to me. We just presented this one. We even without a monitoring system, we using by those steps, we can exactly and very easily find out the location. In another word, we do not need the monitoring system for the RSD. Did that make sense to you guys?
Yes.
All right, so that's a quick summary. So far, we have been sold out 1.8 million devices in the market worldwide. We do not cause any failure causing a fire on the roof. 0 case, 0%. And currently, our failure rate is 0.07%. It's extremely low. The major reason is because we designed our own chips, ASK chips, which our product is the most least components on the PCB board. That been proved by the solar, the owner, the town. He did a study for all the product in the market and take them out, and they count every product, and they come to me say, "You guys are the last components should be have the highest reliability." In
Is that an annual failure rate?
That's the overall.
Overall, so total. So that's not even the annual failure rate. That's overall 0.07% of all. And you've been operating for multiple years, right? So it's
Yeah,
actually, if we're talking annual failure rate, that would be even lower than that.
much lower. Yeah, yeah.
Yeah. Okay. That'd be interesting if you had that number at any time to send it over to us,
Sure.
because that
Yeah,
would be
yeah.
quite interesting. Because we always talk about that. For comparison, if you're talking to like about optimizers, some of those companies, they're claiming like 0.75% as an annual failure rate on an optimizer, or
5%.
1%, maybe 1% annual failure rate, right? So
Oh,
um,
yeah.
so much higher than a rapid shutdown device like this, which has a very low failure rate.
Yeah. That data was is the last quarter,
Yeah, last year.
2022.
Yeah. When did you start selling these?
2019.
19. Okay, so 3 years of. So yeah, that's really impressive. Thank you.
We did have a third party by the PVL. Right now, we're also doing frequently testing with RETC because PVL is not anymore testing the MLP equipment anymore. Certification, we have all kind of requirement in here. You can download directly from our official website under the library section. Customer service, you can directly reach me at this number is our application supporting and also our service team. Our service team located in the US, but you can directly reach out by email, by website. There are 3 ways totally. 1-800 numbers. You can go online portal. There is a section called support. You can fill in the issue you have and the request you have and just submit. It directly go to our service system. And also you can email through this one. So there is multiple way. You never been blocked out from our service team on the market. And we have a 25 years warranty. This RMA process is pretty easy. When this device, if even it failed, it just failed. It's nothing. You don't need too much troubleshooting. Actually, pretty easy to operate. And if you have that one, you just take the request by those 3 functions, 3 methods, and fill out. Well, sometimes even our service team will fill out this one for you and just let you to confirm your mailing address, receipt person, and phone number. Then they will ship out directly within weeks. So the service part is pretty solid. All right. So is there any question?
Looks like you answered a lot of the questions already. Looks like Steve has got another question. Has the AP Smart been tested with Outback, Magnum, or Schneider charge controllers?
I know Outback is the customer is using us because they are major competitor with the Solar. So the same way you connect their customer normally order is outdoor case, and they are using directly connect to their AC load, make sure their PV panel still operating in the grid off. And a lot of actually the off grid application using that way, using outbreak.
And
Uh,
and to add that again, if you're using that controller from AP Smart, it will always work regardless of the inverter, right? Yi?
yeah,
Yeah.
it's
So you can use any inverter at that point, as long as you use that box for the communication.
I'm not sure you guys can see that clear. I prefer this one, but
It's
maybe.
hard because you're filtered in the background. You can't see it.
Oh, no.
Yeah, so you can't see it because it's using like a green screen, I guess.
All right. Yeah.
Good stuff. Well, if there's no more questions, thank you so much, Yi. I really appreciate it. I think it was very informative. And we will be posting this webinar on our YouTube channel as well. If you want to review it afterwards again, or if you have someone else in your organizations that want to see it, they can go on our YouTube channel, and it will be on there. And then, of course, if anyone has any questions in regards to AP Smart, feel free to reach out to us. You can send us an email to sales@frankensolar.ca, or you can reach out to your Frankensolar account representative. I'm sure they will be very happy to help you out as well. So,
Oh, Dan, may I just speak
of course.
one more thing? I just want to give you an update on it. So for the past few years, in the U.S. market, the RSD system is spread out, and each state by state, they adopt AEC 2017 to 2020. Right now, it's prepared for 2022. There is a reason. I just compared to Canada market. There is a reason why U.S. market spreading the RSD so much and so quickly. There is a secret for the RSD, which I learned in the field is the DOE, U.S. government or DOE or Ariel, they didn't speak out that, but they know that RSD actually really can ignore the fire on the roof fundamentally.
Okay.
Right now, the industry worldwide will be spreading by, with more and more years down the road, your reliability was dropping by the system, and it will cause more and more fire. That's true. But what we found out, not only the AP Smart, including the Tiger or whatever, the RSD players and the SoundSpec, we learned is for string inverter. I didn't say the AC side, is AC module or AC microinverter stuff, it still also can ignore the fire. But for the string inverter, on the high voltage DC system, the rapid shutdown device, if they operating or designed properly, they will fundamentally ignore the fire on the roof. And
Okay.
that's the big secret.
Okay, thank you for that, Yi. Perfect. Yeah, if there's nothing else, no more questions from anyone, then thank you very much for everyone's time. And I think we got another webinar scheduled for 2 weeks from now on a different topic. I don't remember what it is, but you will get an email regarding that if you haven't already. I think it actually is on Schletter, their new racking that they have for flush mount. So feel free to join us again in 2 weeks. Thank you, guys.
Thank you. Thank you, Dan. Thank you, guys.